moving into more chain rule. Okay, so if we've got a function to an nth power, how we take the derivative of it, we start with the outside function. So that's why we bring the n down, the number n, and subtract 1 from the exponent, so much like what we do when we take the derivative of x to the n, right? Only we carry the inside function along, and then we multiply by the derivative of the inside function. Okay, so I've got several here. I just want you to watch and kind of absorb. And I want to write along the side to kind of give hints of what can be helpful. Okay, so if this is the function, I want to start by thinking, okay, the outside function is the 4th power. So, get rid of this. Get my eraser working. There we go. I would suggest you write the 4 and then you write the 3. So you're thinking, bring the 4 down, carry the inside along, and it's to the 3rd power because this is so easy to forget. You carry the inside along, and as you're writing this, you're thinking about taking the derivative of the inside. So that's going to be 2x plus 1, and you have to put parentheses around that. And that's what we have. So this one here, again, but I'm just going to write stuff. It's all here, so you can just listen. It might be helpful for you to write that to the 1/2 power first. And then be careful that you use your notation to say, okay, now the derivative is, bring the 1/2 down, subtract 1 from the exponent, carry the inside along, and then multiply by the derivative of the inside. Derivative of 4 is 0, and the derivative of cosine is negative sine. So I'm going to make a comment here. It's not okay just to put a dot there to mean multiplication. It is necessary that you put parentheses. Okay, so this one here, I suggested you rewrite it like this. So then, I'll just use what we have written, bring the negative 4 down, again, subtract 1 from the exponent, carry the inside along, and then multiply by the derivative of the inside. You know this is the same thing, excuse me, as tangent of x all to the 4th power. So again, you could, let me just write it over here, you could say 4 cubed, right? Then carry the inside along and then take the derivative of the inside. So this is the same thing as saying this. I want to make sure you know that. This one here, again, I would take the time to rewrite it before the derivative. Then bring the negative 1/3 down, subtract 1 from the exponent. So you want to leave it as negative 4/3. Carry the inside along, and then multiply by the derivative of the inside. So let's do this one. Here, I would say, take the derivative. It would be 3 squared, carry along the cosecant, and then the derivative of the cosecant is negative cosecant cotangent. All right, so now let's talk about these trig functions when they've got something on the inside. We've done a whole bunch with the exponent on the outside. So here is all the rules. So if I have sine of g of x, you take the derivative of the sine, which is cosine, you carry the g of x along, and then you multiply by the derivative of the g of x. That principle works for all of these. So let's just practice. So here, that cosine is the most outside function. So to take the derivative, it's going to be negative sine, carry the angle along, and then multiply by the derivative of the angle. This one, the cube is on the outside. So I've just put these kind of right together so you can compare and contrast. This is bring the 3 down, subtract 1 from the exponent, carry the inside along, and then multiply by the derivative of the inside. So again, I'm just kind of going back and forth so you can really see the difference. The derivative of cosine is negative sine, carry the angle along, and then multiply by the derivative of the inside. This one here, you might want to take time to rewrite this as x to the 1/3 power. Another thing I want to make sure that you don't do is you start just saying equals negative sine and you continue on with the derivative. The derivative is not equal to the function. So you need to, on the next line, f prime gives you negative sine x to the 1/3, and then multiply by the derivative of the inside. So this is secant, which the derivative is secant tangent. So let me make a suggestion that you write secant tangent, because that's what you're thinking, derivative of the secant, carry the angle along, and then what you're taking the derivative of is actually just that, not both of these x to the 4ths. So you would have 4x cubed at the end. This one is the same thing as saying secant of x all to the 4th. So the derivative would be 4 to the 3rd power. And then multiply by the derivative of the secant, which is secant tangent. This one here, let's finish that off here, f prime, that would give me a secant squared, carry the pi x squared along. Now thinking about taking the derivative of pi x squared, we carry the number pi along, and we multiply it by the derivative of x squared, which is 2x.